For example, we're going to assign oxidation state, mean give a number to that element. For example, we look at the first one, Br. Br, if it's in element, we know that it's either neutral or it's an ion. How we know it's ion? You see there's a plus above the element. For example, B, K plus, SO4, 2 negative. This is negative ion. B, K plus is the positive ion. So either it's neutral or having a positive charge or negative charge. There are three states of the element. A, you see Br2, no positive, no negative, so it's a neutral. So neutral, you read rule number 1 in your tutorial handout. Rule number 1, oxidation state of an atom in a free element is 0. Free element means no having charges, is a neutral. So you are given, you follow rule number 1, how you write the oxidant number. So like this. You break Br2 means there are 2 atoms. You break into 2 atoms. You write Br below the Br. You write 0, 0. This is how you assign number to the oxidation state. Okay, so this is how you use the table. Usually table, this rule for assigning oxidation will be given in the test or final exam. As I mentioned, this question will come out in your test too, for sure, and also for final exam. Make sure you know how to use this table. Okay, then we go to example number 2. Is ion, K plus. K plus, you see there's a plus already. And K, and you compare the BK plus and the E. E is a SO4, 2 negative. You see E got 2 elements, S and O. It's not monoatomic. If only one element it is called monoatomic, like what you see on the B. B only have K and it's ion. So you read rule number 1. Rule number 1 is neutral, so it's not neutral. So you move to step number 2. You move to number 2 because you read number 1 is referred to free element. K plus is not free element. So you move to rule number 2 as you see on the screen. So you read the oxidation state of a monoatomic is ion, it refers to ion, is equal to its charges. So how many charges of K plus? 1. 1 positive. If you see 2 positive, means 2. If you see 3 positive, means 3. Okay? You follow rule number 2. How you write the oxidation state? This one you need to write in your answer. When it comes to test. So you need to write K plus below the number. You need to follow the charges. So this one is 1 plus. So you have to write plus 1. So there is an error mistakes during the test. Don't write plus 1. Don't invert the number. I already explained there is a difference between plus 1 and 1 negative. 1 negative means you're referring to the charge. Like for example, 2 negative. E, 2 negative, you are referring to the charge. If you are referring to oxidation state, the operation sign, positive, negative, is in front of the number. So this is some of the careless mistakes during the test. Just take note in your revision note. So remember on the sign, don't flip the sign. If the question asks you to write oxidation state, please follow the format. For example, B, K plus, you read the rule number 2 as we highlight on the PowerPoint slide here. So 2 is that the oxidation state of a monoatomic ion is equal to its charge. So you look at B equal to its charge. Charge is 1 plus. So below the K plus, you write plus 1 and not 1 plus. So remember that one. And of course, in the exam, you won't see in the table. I will remove the example. I'll purposely remove the example because I cannot give you the example during the test or assessment. Okay, we move to the C. C is 2 element, LIF. So how you do LIF? Again, you read the table. Rules. You always start with rule number 1. Rule number 1, oxidation state of an atom. LIF is not atom, it's a molecule. It's atom plus atom. So rule number 1 do not apply. Rule number 1 is atom. So do not apply. Don't confuse. Okay. So you move number 2. Number 2 is equal to ion. So LIF neutral. No charges is not ion. So move to rule number 3. Rule number 3, you read the sum of oxidation state of all atoms in their 2 scenarios. A neutral molecule is 0, means LIF, the net is 0, no charges. An ion is equal to the charge of the ion. Means if you break Li, you break F, there's a charges. If not, then these two cannot combine one. If you break them, there must be some different charges, like magnet to suck or stick to each other together, like a molecule. Okay? So you move to number 4. In their compound, metals have positive oxidation state. So this one I already explained in last lecture. We need to know how to read periodic table. Periodic table, you have group 1 until group 8, or maybe group 1, 8 or 18. Okay, so group 1, you always follow the group number. Group 1, you write positive 1. And so on. Group 2, positive 2, and so on. Okay? So, for oxidation state of Li, you break into element and then you flip to your periodic table, like I give you in your chapter 1. You refer to the periodic table. It will be fall under group 1. So you give it +1, okay? And you refer to F in the periodic table. It's group number 1 also, okay? Sorry, it's not group 1, but this one you refer to the group also lah. So Li is group 1, L2 is L1 is group 1, F also group 1, if not mistaken. Okay, so you follow group 4 and group 5, and you read what is group 5. Group 5 actually, you need to refer to the hierarchy. It just remind you group rule number 5, you read carefully. Group 5, in their compound, blah, 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 until the last sentence, entries at the bottom, it actually refer to the hierarchy table. Refer back here. And this is the table. This is the table that I mentioned just now. We assume you already know. This one might be given or might not given. This small table, this one, we assume you already know. Like gravity, 9.81. Here in chapter 7, we assume you already know this small table. Means if you see fluorine, F in the equation, you straight away give -1. You don't need to think one. This one is like, you assume you already know. Hydrogen, if you see hydrogen, straight away give +1. Oxygen, straight away give -2. Group 17. Group 17 means group 7 in the periodic table. You straight away you give -1. Why -1? Because if you read the periodic table, group 1, 2, 3, they have how many electron valence outside? They have 1 electron valence, 2 electron valence, 3 electron valence outside the atom or molecule, right? So group 1, 2, 3, they are more easier to give away the electron. But group 5, 6, 7, because they have many electrons outside and have a very large positive charge inside the nucleus, so they are more easier to pull electron from outside. So for example, group 17, because there are 7 members outside the most outer orbit, so they will pull 1 member in. That's why you give -1. 16, why -2? Same theory also, or same concept also. You have 16 means you have 6 members outside the electron. You want to reach octet. How you do? The most easier one is to pull 2 electrons outside. So you put 2 there, -2. Group 5, also same. You have 5 members outside. The easiest way, 5, 6, 7 is to pull member. Right? To reach octet, group number 15 or group 5 is to pull 3 electrons from outside. So that's why we give -3. Okay, so this is from the concept of periodic table. The 1, 2, 3 is based on the periodic table. Yeah. Only need to be careful on the fluorine. Okay, fluorine is -1, hydrogen is +1. This is also the careless mistakes part during test or final exam. Yeah. Right. Now from here, LIF, back to this question, LIF, you see fluorine already. You follow this small table. Fluorine, F is -1. Okay. So Li is +1, referring to the periodic table, is 1 charges. Group 1 is group 1 means is more easier to push away 1 electron or give away 1 electron. So you have Li, below the Li, write +1 and not 1 plus. Again, don't write the inverted one. Li, if the question asks you oxidation state, the plus signs or negative signs should be in front of the number, like for example, this Li. Okay, fluorine, straight away, memorize, fluorine F should be -1. Okay, so the sum, then you need to do the sum. If you have 2 atoms, 2 different atoms, you need to do the sum. So how to do the sum? You take +1, take the -1, sum together, you get 0. It will agree with the molecule, LIF, no charges. If the molecule no charges, if you do the sum got number, means your calculation is wrong. In this case, Li, above the Li, there's no charges, so the sum must be 0. If in your calculation, if a neutral molecule, you sum up, you get one number, means something wrong in your oxidation state. You need to check your oxidation state. Yeah. So this is a neutral compound. So sum of oxidation state is 0, like this one. Okay, like rule number 3 on the screen here. Understand? So basically, these rules number 1, 2, 3, 4, 5 actually is a guideline. Answer already inside the table. You only need to follow only. And then recall back the periodic table. What does a periodic table group 1, 2, 3 means? Group 5, 6, 7 mean. Group number 4 a bit dangerous. It's a gray area because group number 4 got 4 members outside. It can either pull, it can either receive to reach octet state. Understand? Okay, good. Okay, can Brian? Okay, good. Now we move to another example, CO2. You know, you look at CO2, got charge or not? Charge or not? CO2 got charge or not? No charge, right? CO2 no charge. So you know that when you do the net of the oxidation later, you get 0. So you break C, you break O. Again, in the small table just now, there's O, right? O straight away give -2. C, you need to refer to periodic table. So how does it do? So you see O already straight away give -2 based on this small table. Oxidation states, you must follow rule number 3. It must be neutral. What does it mean? It means you need to work out your equation. So how you write oxidation state in short form? You take bracket, write C, then write OX state. Means I know that you are trying to find the oxidation state number, plus 2 O, because CO2 CO2 got 2 oxygen So C oxidation state plus 2O oxidation state equals 0. Why 0? Because this molecule is Why 0? Ryan, why 0? Because it's neutral, huh? Then you know the number of oxygen already. You substitute and solve the unknown C. Okay? You move around, just be careful on the careless mistakes, minus. When you move minus, it becomes plus. So, in this case, carbon is +4. So how you write the oxidation state? Remember, you need to check your answer in the test 2 and also final exam. You need to write sum equal, then take the oxidation state number +4 +2 bracket -2 because CO2 got 2 oxygen equal 0. Then you need to break, you need to write something like this on the screen. You need to break the element C. Under the C, you need to write +4 and not 4 plus. Don't confuse the sign. If you write 4 plus means you are referring to the charges. We are referring to oxidation state in these slides. Same with O2. O2, you write -2. Although there are 2 oxygen there, but we know that oxygen is -2. Understand? So this will be the careless mistakes part lah. So just be careful in your test 2 and final exam. Let's move to E. Okay, move to E. So E is SO4, 2 negative. So from here, before you solve, you know, net oxidation number is how many? Net oxidation number is, what is the charges? 2 negative. So 2 negative should be -2. Don't write 2 negative. Net number, net oxidation number is -2. Don't confuse the number. Okay. So again, you need to always remember the small table. If you see fluorine, straight away give -1. In this case, no fluorine. Is there hydrogen? No hydrogen. But if you see hydrogen, you give +1. If you see oxygen, you straight away, you don't need to think one. You see oxygen, you straight away give -2. Then group 17, -1. Group 16 means group 6. -2. Group 15 means is -3. This one, you read the periodic table. Okay, in this case, SO4. So the first step, you see oxygen already, write oxygen. What is the oxygen number? You write oxygen number, oxidation state of oxygen is -2. You need to write this statement. Write this statement in the answer. If the question asks you, assign an oxidation state for each atom in each species. Okay, so then you solve oxygen already. So if you do the calculation, you know S is -2. Okay. So rule number 5 means you need to refer to the periodic table. So in the margin, in the margin means this one. S, you need to refer to table. S maybe is group 17 or S is in here is group 16. Right? So group 16, you need to refer to here. Group 16 is -2. So S, you refer to periodic table. In this case, I straight away give you the answer. In the test, you need to refer to answer to periodic table in the question sheet. So S is 16. So straight away you refer to -2 for S. So, however, if there were a case, the sum of oxidation state would not equal the charge of the ion. Because why? You take S plus O4. O4 means is 2 negative, means this side 2 negative plus 2 negative means is 4 negative already. You won't get 2 negative. Right? So it will not equal to charge. So you need to do something. So how to do? So you look at the small table here. Small table here, okay, group number 5, if you look at group number 5, means you need to recall this small table. Okay, hierarchy table shown in the margin, it means this small table. Okay, so group 16 is below oxygen. So oxygen is above group 16. So you refer to oxygen first. Means you give the oxidation state number to oxygen first. Then you balance the total equation. Understand? Huh? Okay, huh? Brian, okay? Huh? Okay. So again, that's why I book a note here. Since all have a higher in the list, it take priority. What does it mean? You see here, huh? You write the oxidation state equation, bracket S oxidation state, close bracket, plus 4 bracket oxygen state equal -2. Don't write 2 negative. It's -2 because you're calculating oxidation state. Okay. So you substitute the number. It's a normal mathematic. You know that in the bracket of oxygen is -2 based on the table in the margin, the small table. Oxygen is -2. Then you balance the oxidation equation. Okay. 4 bracket -2 is -8. You move to the from left to right. Negative become positive. Okay. So as oxidation state is +6 and is not +2 or -2. Yeah. So this need to take note lah. Need to take note. This is a special reminder for your test. You'll see something like this in your test, but not SO4 2 negative. You will see another element with maybe 3 negative or 3 plus. Okay. Some need to check again. When you find the S, one of the element oxidant state equal +6, you need to check whether the sum correct or not. So +6 is the S, then 4 bracket -2 equal -2. So you check left hand side equal to right hand side. Then check already, then okay. Understand? This is how you use the table. There are 2 tables. One is the big table, rules 1 to 5, and then table in the margin, which is this small table. This small table, very high chance I won't give you, but I expect you to memorize. Okay? Hey, any question? Good, huh? Okay. Okay, then remember when you calculate, remember to write the oxidation format as under there +6 and not 6 plus. S, and then under the S, write +6. Then O4 2 negative is -2 because it's oxygen. Don't confuse by the 2 negative charge. Don't confuse by the 2 negative. Okay? Okay, sorry. O4 2 negative, why is -2? Because you refer to rule number 3. An ion is equal to its charge of the ion. So O4 2 negative is actually maybe I should not write but you just follow the slide lah. So it's like that. So okay, let's move to the last example. N2O2. N2O2, the net oxidation state should be 0 because it's neutral. Then you read number 1. Oxidation state of an atom of a free element is 0. This one is not atom, it's a molecule. So rule number 1 do not apply. Okay, then you move to number 2. Oxidation state of the monoatomic ion is not ion. It's not monoatomic. So rule number 2, you can skip. Okay. Then rule number 3 asks you to find the sum of oxidation state of all atoms. So a neutral molecule formula unit is 0. So this is a neutral molecule, 0. An ion is equal to the charge of the ion. So when you break Na2, break away, O2, you break away, they will have charges. Okay, so we stop at here. Then before we move to number 4, number 4 also actually referring to periodic table already lah. Okay, you try to move the Na2O. So sodium, sodium or Na, Na is group number 1 if you refer to periodic table. It's group number 1. So Na will be +1. Or you know from the side table or from the margin table, O is -2. And not too negative, -2, because oxygen you need to memorize. Okay, so Na rule 4 priority over O rule 5. Because Na is here. Na rule number 4 is refer to periodic table. Rule 5 you refer to the small table. Rule 5 is oxygen, hydrogen, fluorine, group 17, 16, 15. Only 3 elements here, 6 elements here. But if you see oxygen and Na, you need to be careful a bit. So Na is group 1. Group 1 +1. Because Na is in the rule number 4. Oxygen is rule number 5. So rule number 4 win over 5. You give priority to Na. So when you do the sum equation, you do the Na first. Then only you do oxygen. Be careful. If you involve group 1, 2, you need to be careful. This is rule number 4. It gives you the final example. So when you do still, you need to write the oxidation equation. If you see 2 atoms, Na2 means 2 atoms of Na. You write 2 bracket Na OX state. You can write the full name of oxidation if you want, but if you only write OX state, I give you correct answer, right? Plus 2O OX state means because in the equation you have 2 atom, oxygen atom, equal 0 because it is neutral molecule. Okay, in this case, okay, in the previous example, we always give oxygen first, right? But in this case, because rule number 4, because Na is in group 1, group 2, if you read the periodic table, in group 1, group 2 already, you need to do the group 1, group 2 first. Means this side. This example, you need to do Na first. Okay, just highlight here. Don't always oxygen. You need to read periodic table, whether the element inside group 1, group 2 or not. Means the first column and second column of the periodic table. Does it inside there or not? If inside there, then do the group 1, group 2 element first, before oxygen or before the one in the margin. Okay, in the margin only have got sec member only. Fluorine, oxygen, what else? Fluorine, oxygen. What's that? This one. Fluorine, oxygen, hydrogen. These 3, fluorine, oxygen, hydrogen, then group 5, 6, 7, or group 17, 16, 15. Even within this table, you need to give priority based on hierarchy. If you see fluorine and hydrogen, you need to calculate fluorine first. If you see oxygen and hydrogen, you need to give hydrogen first. Because hydrogen is above hydrogen. Understand? So when you memorize, you need to memorize the sequence. Fluorine, hydrogen, oxygen, group 17, 16, 15. Can I? Okay. So here, when you write this equation, you already know Na is group 1, rule 4, have higher priority over oxygen. So you do nitrogen first. So you write nitrogen first, then you solve for oxygen. Okay, so you write 2 bracket plus 1 and 2 OX set, you solve for the unknown O. Okay, plus 1 multiply 2 plus 2, move to the left to right, become negative 2. Negative 2 divide by 2, negative 1. Understand? This mathematical equation makes sense to you? It doesn't make sense, you need to tell me. So this is how you calculate the oxidation state number. Okay. So after you calculate the oxidation state, you check whether correct or not oxidation number. You do sum of the equation. You write sum double dot 2 bracket Na is plus 1 plus 2 bracket oxygen is minus 1 and not minus 2. We are talking about oxidation state and not charges. Don't confuse between oxidation state and charges. We talk about oxidation state. So when you do the sum plus 2 minus 2, you get 0, which is correct. Then remember to conclude your answer. With this, how you write? Na 2 below there plus 1. Means you break the molecule. Na 2 below there plus 1. Then you break O2 below there minus 1. So this one, it tells you the difference from example A until F. This is how we apply the big table with its rule 1 to 5 and the small table with its in the margin with this one. Cannot. This example, this one is important again, important for your test too. Okay. All right. Okay. Now we go into electron booking. Okay, electron booking. Electron bookkeeping. I think we gone through. Okay, not yet. Okay, let's consider a redox. If in the question you see redox reaction is fall under chapter 7. Don't use chapter 1 until chapter 6. Chapter answer to answer chapter 7 question. Don't confuse. And chapter 7, we always consider gas state only. We only consider gas state. Okay. I don't gas state, but can say we consider ion. I know. Chapter 6 is, sorry. Chapter 7. Oh, chapter 6 is gases. Chapter 7 is mix. Okay. Okay. So if you see a reaction C plus 2S, then arrow from left to right means it's a forward reaction. CS2. What is oxidate here? What is reduced? So how you know? So recall back, if the question asks you what is oxidized, means the element that having oxidation. And previous lecture we learned about agent, right? You see agent means it's opposite, some opposite meaning. Okay? So here we use oxidation state rules to assign oxidation state to all elements, both equation in the equation. Now, previous lecture, we use oxygen and electron. This is the third method of deciding whether the element is having oxidation or reduction by assigning oxidation state electron bookkeeping method. Yeah? So we write like this. C plus 2S forward reaction C and S2. When you write oxidation number, you need to break the molecule. C is 0. S is 0. You understand why 0, right? Why 0? Because the atom C, no charges. Atom S or molecule S, 2S, no charges. So oxidation number 0, 0. However, if you break C and S2, like you recall back the previous tutorial question that we just discussed 5 minutes ago. S and C and S2 you break, it becomes 2 molecules. Then refer to table, rule 1 to 5, and the small margin table. I assume you already understand, huh? So I straight away give you the number already. Okay, huh? Okay, we do all the steps by the previous example. We get C is plus 4, S2 is minus 2. Yeah. Yeah, Brian, I got any question? No, huh? Okay. So this one is your homework, huh? You guys prove CS2, Y is plus 4, Y is minus 2 is your homework, huh? Go home and do. But I assume you already understand. If you understand the previous example A to F just now, you should be able to understand plus Y, C is plus 4, S is minus 2. Okay? Right. So, you see, huh? The oxidation state of carbon, you have to see before and after. This is the forward reaction, means from left to right reaction. So you look at individual element. Carbon oxidation state from 0 to plus 4. Right? Carbon oxidation state, carbon from the left hand side is 0. Forward reaction, after forward reaction, carbon oxidation state become plus 4. Agree? Then sulfur S oxidation state 0. After the forward reaction, it becomes 0 to become minus 2. Agree? Then it's mathematical steps already. So this is the third definition. Huh? Means by the bookkeeping, we have defined oxidation state means what? Oxidation earlier, either plus oxygen or give away electron, right? Correct? Oxidation state either plus oxygen or negative electron, right? Means you give away electron. Correct or not? How carbon C become positive? Why become plus 4? Means it give away electron already. That's why you get positive number. Understand? Huh? Don't confuse between electrical charge or electron valence charge and oxidation number. Huh? Don't confuse these two things. In this case, carbon 0 to plus 4 means how to get plus 4. You can take it as give away. If you give away, it become positive. Okay. Now by looking at the 0 to plus 4, okay, carbon lost electron and was oxidized. You need to write this statement in the test. You need to tell me why is it oxidized. Work back this statement. Okay, you need to copy the general equation, then do the oxidation state calculation just now. Below the element, write the oxidation state. Then write this statement. Oxidation state of element A, in this case, is carbon. How it changed? Change from left-hand side to right-hand side. So you see the number in your calculation. In this case, 0 to plus 4. Then you write another statement for another element. So if you have 3 elements, you need to write 3 statements. In this case, sulfur from 0 to +2. So then after that, you need to continue. What does this 0 to +4 mean? It means carbon lost electron and was oxidized. You need to know how to write this one. Huh? You need to write the yellow color key answer. And if one element is oxidized, another one is called what? Reduced. Correct. You need to write, huh? In another one, you need to write sulfur gain electron. It's a keyword, huh? You need to write sulfur gain electron and was reduced. You need to write this statement. Understand? Yeah, so we have spent like almost half an hour just to explain the oxidation state. And what does the oxidation state number tell you? If from one number become positive number, it is oxidized. If one number become negative number means what? It receive electron. It receive electron means it become negative charge, right? So it is reduced or reduction happen. Don't interchange the reduction, the oxidize and oxidation. Don't put in the same sentence. Oxidation is a process. Oxidize with ed means it linked to one element. So when you write, oxidation happen on element 1. If you want to use the oxidized ed, you need to write what element is oxidized. You cannot write element, you cannot write carbon lost electron and was oxidation. Cannot. It's wrong. English wrong. Don't write the thing. What is important? This is what we're looking for in your test 2 and final exam. You need to change, you need to add this blue arrow and red arrow into your answer. You need to represent the blue arrow with the dotted line, red color with the solid line of arrow. Understand? So you need to write, you need to draw arrow, carbon C with the blue arrow. You need to point me the direction from the left to right. And then under the blue arrow, you need to write oxidation. This is where you write oxidation word, and not oxidize. Don't write oxidize. Don't write ed in the blue arrow under the blue arrow. Arrow, you need to write the verb on. Sorry, not verb, is noun. You need to write the noun. English noun means oxidation and not oxidized. Below the red arrow, you need to write reduction and not reduced. Understand? Because there is an intersection, so in your intersection of arrow, you need to differentiate your arrow in the test by one is using solid line, one is using a dashed line, for example. Unless you bring in a color pen in your test. You bring in purple color pen or brown color pen, different color pen, green color pen or black color pen. Then you can use this one. Understand? Good, Okay, we have 7 more minutes. So this is your revision note, Revision note. Third definition of oxidation and reduction. If you see there is an increase in the oxidation state number, means oxidation happen. Understand? Understand? If you see a reduce of oxidation state number, reduction happen. Yeah. Okay. Now we play with the word game word. You know that C is oxidized, right? C is oxidized. So C is oxidized. So C is what? C is what kind of agent? C is oxidized. So it's a Reduction agent is opposite meaning. You need to write opposite. Opposite means the meaning. Huh? Understand? Huh? So C having oxidation, it is the reduction agent. So sometimes the question asks you, identify reduction agent, means in this case, carbon. Okay? So if the question asks you, in C plus 2S becomes CS2, what is the oxidation agent? Powerful, huh? Because 2S become reduction. So reduction, that element is the opposite meaning. So it is an oxidation agent. You see, agent means opposite meaning already. Now, don't confuse with this one. Sometimes in the test, we play with word. So you need to identify this one. So it's good that you understand the blue arrow and red arrow. Huh? It's important. Again, just to summarize, in this chapter, we have three definitions of oxidation reduction. First, you look at in the visualize, if it's add oxygen, which is you learn in your SPM level, if it's add oxygen, it corrode, become rust. Or you remove oxygen, it become reduction. Then the second definition is loss of electron movement. If it's loss or give away electron, it is oxidation. If you receive electron, it is reduction. Third definition by using oxidation number. If the number become positive number, is oxidation. If oxidation number become negative value, then it's reduction. As you clear all this, then you can do chapter 7 question. Okay, I'll show you very quick before we go. Okay, so if you understand what we have covered so far, we apply what we learned. Use oxidation state to identify element that is being oxidized and element that is being reduced in the redox reaction. You see, in the redox reaction means chapter 7 question already. Chapter 2 question, you need to straight away at the side of your answer, you need to write a small hand notes there. Reduction, oxidation, then O2 plus negative O2 plus O2. Then you need to write plus electron, negative electron, like this one at the side of the answer sheet or in the question paper there. Okay. Then you can plus what you can add one more column with the oxidation state number. If it's become positive, it's oxidation. If it's negative, become small number, then it's a reduction. Okay, by looking at this, how many input you have? You have 2 input, which is Ca element 1 and H2O element 2. Then you have the product. You have 2 product, CaOH2 bracket aqua and H2G. Yes. You see the step. Observe the step first. Okay, step down. What we do? We do the calculation for oxidation state. Okay. You just copy, just copy this one. So you do calculation, your hands-on calculation, you write oxidation state. It means you assign Ca, solid, no charges, straight away 0. 0 there, 0. Then H2O is a molecule. You need to break them and do the calculation. H2O. H2O neutral means net of oxidation for H2O equals 0. Then H2O, you need to refer to rules and small table. The small table gives you hydrogen above oxygen. So you need to calculate hydrogen first. The hydrogen above oxygen. But the equation must be 0. That's why you get H2 is +1, oxygen 2 is -2. Understand? Question or not? This one. Can I understand? Okay, then you calculate for CaOH2. This one you break Ca, you break OH. Got O and H. So you need to break 3. Means you break Ca, O2, H2. You need to break three molecule, 3 atoms, sorry. That's why under Ca is +2, oxygen -2, H is +1. Also using the rules that we have, rule 1 to 5 and the small table. So you get +2 -2 +1, H2 neutral 0. Yeah? Yeah? Okay. Then you slowly, Ca. You look for Ca, Ca, 0 to +2. 0 +2 oxidation positive. Positive oxidation. You draw arrow, blue arrow. Under the blue arrow, you write oxidation. Then go to the water, H. 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 H +1 become 0. +1, 0 means negative number. It's a reduced number of OH. Reduce means reduction. Yeah? Any question for blue arrow, red arrow? Make sense, huh? Okay, so this is just a hand note. So why we do not calculate for oxygen? Why? If you look at oxygen, number -2 become -2, neutral, doesn't change. So you don't need to do any judgment for oxygen. Okay, read this note. Note that oxygen have the same oxidation before and after, and therefore neither oxidize or reduce. Sometimes the question give you a bonus mark question. It asks you, what is the oxidation state for oxygen in the equation? So you need to explain based on oxidation number. You take oxidation number before and oxidation after is the same number, then you need to put in. Therefore, neither oxidize or no, it is English. Neither oxidize nor reduce. Understand? You have class after this? You have class after this? No. Brian, you have class after this? No. Okay, we go through this one very fast. I just show you the step. Observe the step. The rest you can copy from the slide later. Observe first. It gives you an equation and then ask you which one is oxidized and reduced. So basically, you see there a question, go to the side of the question, your answer there, write the hand note, reduction, oxidation, then write oxygen plus and negative, and then electron, and then oxidation number. Write that kind of hand short note first. Then you look at the question. First step, always answer, calculate the oxidation state number. Yeah? See how we do? Oh, sorry. So this is your homework. Okay, your homework. Okay. If you don't know, you practice and then maybe you can ask your good friend ChatGPT. Tell me how to assign oxidation state for this equation. Then it will give you the step already. Yeah? Maybe we go deep a bit. Okay. So how we balance the redox equation? We balance through a procedure, half reaction method of balancing. Just now is oxidation reduction, so we already finished that part. Now we want to balance the equation. Sometimes the equation is not logic, so you don't want to find. So just observe. Just observe the step first. Understand the step first. Okay. Step 1, you break the general equation into half equation. Means element 1, how it break. Element 2, how it break. Let's say A plus B equal to C plus D. So how do A arrive at C and D, or how A becomes C? Okay, do the half equation first. Half equation means you do the reduction and oxidation equation. Okay, step 1, do half equation. Step 2, balance the equation. Means you do mathematics. Observe the step. So how we balance the equation? If the question purposely asks you to do 7.4 steps, a section, means you will see in your answer, use half reaction method in the balancing of balancing. Means you need to use the step shown in these slides already. Understand? Okay. So yeah, balance them, add them together like normal mathematics. Just observe the step. Just observe the step. And you need to do more exercise. It become a muscle memory already. So observe the steps. You see a general equation. In this case, AL plus AG become AL plus AG. Okay. Now, without any exercise or any chonteng here, AL become AL3 plus. What does this process? AL become 3 plus. Means what? It let go, right? Let go is oxidation. Right? Ag plus become Ag. What does it mean? It receive electron, right? Plus become 0 plus. Means you plus 1 negative charge, right? You receive means reduction. This one in your mind, in your map already. You see this question, you know which one is reduction, which one is oxidation already. Without calculating the oxidation state. This is the fast way. You see, or you know, okay, which one oxidation, which one state. Okay. But if the question asks you to do these steps by using half method, half reaction method, means you need to show me what is inside your brain. By showing this one you're familiar already, right? Oxidation state, blue arrow, red arrow. Any question? No, right? Means you calculate the oxidation state, 0 plus 1 plus 3, 0. So that, do half equation. Means you write AL, blue arrow equation, red arrow equation. Observe, You understand? You understand this blue color and red color half equation? Means I want to see you know how to write this one. This is called half equation. Okay. Now from half equation, okay. So this one you read half equation. If the question asks you to write half equation, what does it mean? It means we want to see where does the electron come from. You need to write plus 3 electron. When you have 3 plus, you need to balance become 0 on the right hand side. Yeah. For aqua also same. Ag also same. Ag is gold. Also same. What we want to see is the blue color electron. Understand? The rest you read. Okay. You need to do simultaneous equation solving. You know what is simultaneous equation? Means you have 2 equations. 1 equation, 2 equation. But you want to balance the equation. Means you want to balance the electron. First equation, you get 3 electrons, right? Right? Second equation, you only have 1 electron. How you find another 2 electrons? Like how you find in the same process, 3 electron was involved. Minimum 3 electron is involved in the process. So how you balance the equation? Means equation Ag, you multiply by 3 to get the 3 electron. Understand? Understand? That's why I write here 3 plus. You need to balance the equation. So at the end, what we want to see is this one, this equation. So there's a following steps. So first one, you solve for reduction oxidation like what we did previously. The next step, you see the question asks you to solve by half equation. You need to show me this equation. Then you balance it. You need to show me how you cancel electron. Means left hand side to right hand side, cancel 3 electron. Then you write the equation. Then you balance, you pull down all the equation. Left pull down, right pull down. So 3Ag you write, Al you write, Al3 plus you write, and then 3Alg. This is how you balance the equation. You see, so you see our original or equation on the top is not balanced because 3 is missing for Ag. Understand? Understand not? The orange color one. Yeah. So yeah. So this is the side note. Reactant, what does it mean? Reactant means the one on the left hand side of the arrow. Product is right hand side on the arrow. Reactant side, 1 Al means 1 Al, 1 aluminium, 3 Ag, and 3 charges. We did this one. 1 Al is here, 3 Ag is here, and it involves positive 3 charge. Okay, so this is how you balance the equation. Yeah. Observe the step again. Balance, if you see balance means you need to write the half equation already. Go very fast. Do the oxidation state number, calculate. Draw the blue arrow, red arrow. Do the reduction oxidation stuff. Then step number 2. Okay, this step is important. Sometimes final exam asks you to show me the step. You need to write step 1, do what, then show me the step. Step 2, do what, then do the step. This way of answering, we already seen it in test 1 already. I ask you steps. Step 1, do what, step 2, do what. Okay, so once you have that, you need to balance. Okay, so this one, you need to read a bit. Balance half to the mass by this arrow, by this order. Balance all element beside O and H. Means you balance other element by not looking at the H and O. Yeah, means if you balance, you don't care about H and O first. You do other element first. Once you balance everything, if you see O, if you see O in your equation, you plus oxygen, water. Oxygen will become water in the reactant, in the right hand side of the equation. If you see H, on the right hand side of the equation, you write +2, plus H. This is a hidden rules in the balancing the equation, electron. Balancing the equation. First, you balance anything outside O and H. If you see O, you add water at the right hand side of the equation. If you see H, you plus H plus N at another side. Okay. So this one you should able to understand, right? Understand? Then why 1 plus 2, 1 multiply 2, 3 is because we want to find the common coefficient for the electron. Because it got 3 and 2. 3 and 2, what is the common coefficient? 6. Because we want to solve the equation. Okay, 2 and 6. Then you put the two equations together, draw a blue line, pull down all the numbers. -6 on the left, you need to remember to show me the cancellation of arrow. Cancel the red color 6e, both sides, like this, like what you see on the screen here. Then pull down. This is the answer that I'm looking for. Just pull down, pull down, pull down, and then you get the final answer. Yeah? Okay, so this is the side note. On the left-hand side, 2 Al, 3 Cu, and 6 plus charge. Right-hand side, product, 2 Al, 3 Cu, and 6 plus. Okay. This one, your homework, go and do revision. If you have question, come and ask me. Yeah? But basically, we are keep repeating the same steps. Yeah? Okay, so this is also your homework, this example. Go home and have a look. Same step actually. What we do, we also same steps, but need to go through because some of it got special case one on careless mistakes area. This is a H and O example. Go home and read. More and more steps, but go ahead and read. Go and read. O become OH. Maybe I will just stop here. I'll just stop here in this slides. Okay, I stop here. We continue on Thursday. Yeah.